welcome to Homeschool. This is your Class 9 Mathematics NCERT or CBSE board. We are in our Chapter 7 Quadrilaterals, Exercise 7.1, your problem number 7. ABCD is a rhombus. Let me draw a rhombus here. ABCD. ABCD is a rhombus. Show that diagonal AC. We need to draw the diagonal AC. Diagonal AC bisects angle A as well as angle C. And diagonal BD bisects angle B as well as angle D. So we are going to divide this problem into two cases. First one using diagonal AC and your second one using the diagonal BD. Given ABCD is a rhombus, show that diagonal AC bisects angle A as well as angle C. What do you mean by bisecting? This angle is equal to this angle. AC is a diagonal, it is bisecting angle A means this angle is equal to this angle. Bisecting angle C means this angle equal to this angle. So let me mark the number for angle 1, 2, 3, 4. Okay, 1, 2, 3, 4 are the angles. AC is a diagonal, bisecting angle A means angle 1 is equal to angle 2. Bisects angle C means angle 3 is equal to angle 4. We need to prove this. They have given only ABCD is a rhombus. And one more condition what we need to prove here. Prove that BD diagonal bisects angle B as well as angle D. Same manner we need to take 4 more angles and we need to prove that they are equal. Okay, let's start a solution. Given ABCD is a rhombus. ABCD is a rhombus. We need to prove that. To prove, if you want you can write to prove also. To prove AC bisects angle A and angle C. Next, BD. These two are what? Diagonals. Diagonal AC bisects angle A and angle C you can write. Or simply you can write AC bisects angle A and angle C. BD bisects angle B and angle D. Proof. Consider any one triangle of your choice. You may take this triangle or this triangle. But choose only one triangle. Which one shall we take? Okay, this triangle ADC. Consider triangle ADC. Observe carefully. What all you remember in a rhombus? Adjacent sides are equal. For a rhombus, adjacent sides in the triangle means AD is equal to DC. Write that one. AD is equal to DC. In a rhombus, adjacent sides are equal. If these two sides are equal, immediately you remember some triangle. What it is? It is isosceles triangle. If two sides are equal in a triangle, their opposite angles are equal. Do you remember this point? So according to that point, this side opposite angle is angle 3 and this side opposite angle is angle 1. AD opposite angle is angle 3. DC opposite angle is angle 1. AD equal to DC, in a rhombus adjacent sides equal. If adjacent sides equal, their opposite angles will be equal. This one, in rhombus, adjacent sides are equal. In rhombus, adjacent sides are equal. Okay. And this line, how did you write? If two sides are If two sides are equal in a triangle, their opposite angles are equal. Their opposite angles are equal. Compulsory, you need to write a statement. If you write any statement, how you have written, by which concept you have written, you should know, right? So what you understood, you need to write in brackets. How did I write this root 3 equal to root 1? If two sides are equal in a triangle, their opposite angles are equal. Angle 3 is equal to angle 1, mark it as first equation. But I remember something, what it is? Angle 3 is equal to angle 2. How? Alternate interior angles. Alternate interior, where do we hear this word? If this acts as a transversal, then these alternate angles are equal. That means, I write here, but angle 3 is equal to angle 2, I know. Alternate angles, I say this one. Mark this second equation. Now compare these two equations. Angle 3 is equal to angle 1. And I know equal to alternate angles in a rhombus are equal. Angle 3 is equal to angle 2. When you compare these two equations, compare here carefully. These two are common. If these two are common, you can equate these two. From 1 and 2, we say that angle 1 is equal to angle 2. Angle 1 is equal to angle 2. This is the thing we need to prove, right? Angle 1 is equal to angle 2. That means AC diagonal bisecting angle A. Still we need to prove this AC diagonal bisecting angle C. Now observe carefully here. Angle 1 equal to angle 3 and angle 3 is equal to angle 2 by alternate, I have said. Only this pair is alternate. No, this pair is also alternate. Hence, here one more pair of angles are equal. That is, angle 1 is equal to angle 4. By alternate angles, I say these two angles are equal. By alternate angles, these two angles are equal. Mark this 3 and mark this 4. Okay, now don't compare these two. Look here carefully, don't compare these two. If you compare, what happens? Angle 2 equal to angle 4 you will get. So don't do that. Again compare this one. Which one? First one. From equation 1 and 4, compare these two. Angle 1 is common in both. Angle 1 is common in both. And I say that from 1 and 4, I say angle 3 is equal to angle 4. Now observe here. Yes. AC diagonal bisects angle C also. Therefore, what is the statement you are going to write here? Therefore, diagonal AC bisects angle A and angle C. Therefore, diagonal AC bisects angle A and angle C. Right? One more part we need to prove, that is diagonal BD bisects angle B as well as angle D. So, in order to prove BD diagonal bisects angle B and angle D, we are going to draw one more rhombus, but the same diagonal will be in this. Instead of disturbing this figure, I have drawn one more. But both the diagonals from the same figure, children. Okay. BD diagonal I am going to take now, and I will prove that it bisects angle B and angle D. Same manner how you have done this, same manner. In these two triangles, any one triangle you consider. Let me consider the triangle. Consider, or in triangle you can say, consider you can say triangle ABD. Consider triangle ABD. I say that AB is equal to AD. adjacent sides in a rhombus are equal. If these two sides are equal in a triangle, their opposite angles are equal. That means AB opposite angle is angle 7, AD opposite angle is angle 5. Mark this one 5 children and mark this 6. Angle 7 is equal to angle 5. Now, we know that already. What is that? Alternate angles are equal. I say that angle 7 is equal to angle 6. But angle 7 is equal to angle 6. How can we say this? Alternate angles. I say that angle 7 is equal to angle 6. Now again, compare these two. Mark this 7. Compare these two. Angle 7 is common. So equate these two angles. From equation 6 and 7, I say that. From equation 6 and 7, I say that angle 5 is equal to angle 6. That means diagonal BD bisecting angle B. Next one. Now, not only angle 7 is not only equal to angle 6, and angle 5 is also alternate to angle 8. Write that one and mark this 8. Angle 5. Hence, we know that angle 5 is also equal to angle 8. But what did I say, children? Don't compare these two. If you compare, you won't get the answer. Which one you need to compare? Angle 5, angle 8. Any other there? Yes. From 6 and 9, I say that angle 5 and angle 5 common. Angle 7 is equal to angle 8. You can equate. Angle 7 is equal to angle 8. So observe in figure. Yes, it is bisecting angle D. Therefore, if you want, you can mark 10. Therefore, diagonal BD bisects angle B and angle D. So finally, what is your final statement here? From equation 3, 5, 8, 10, I say that therefore in this rhombus, AC diagonal bisects angle A and angle C, BD diagonal bisects angle B and angle D. Therefore in rhombus ABCD, diagonal AC bisects angle A and angle C, and diagonal BD bisects angle B and angle D. That's it. Okay, let's see once again this one. Given ABCD is a rhombus and they asked us to prove diagonal AC bisects angle A as well as angle C, and diagonal BD bisects angle B as well as angle D. So first we have taken one diagonal. ABCD is a rhombus. Given what we need to prove, we have written here. And first consider any one of the triangle. Any one, children, you can take this also. In rhombus, what do I remember? The adjacent sides are equal. AD equal to DC. If these two sides are equal in a triangle, I remember isosceles triangle. If two sides are equal, their opposite angles are equal. If these two angles are equal, immediately I remember these angles are alternate to one more angle. Right? Angle 3 is equal to angle 1, but angle 3 is equal to angle 2. On comparing, you say angle 1 is equal to angle 2. Not only this pair, angle 1 is also equal to angle 4. When you compare 3, 1 and 1, 4, you get angle 3 is equal to angle 4. There you can say AC diagonal bisects angle A and angle C. And next, draw one more diagonal in this. If you are able to identify in the same figure, you can draw here itself. While you are proving, if you feel difficulty, then roughly you can draw another figure. Okay. So ABCD is a rhombus. Draw BD diagonal and same manner consider any one triangle. We know that in a rhombus adjacent sides are equal. If those two sides are equal, their opposite angles are equal. And those angles are alternate to another angle. When you compare the pair of angles, we are going to say that this BD diagonal bisects angle B as well as angle D. Let's see the 8th problem. ABCD is a rectangle. You can see the rectangle here. ABCD is a rectangle in which diagonal AC, this is a diagonal, AC diagonal bisects angle A as well as angle C. If it is bisecting, these two angles must be equal. That is, angle 1 equal to angle 2 and angle 3 is equal to angle 4. I repeat the question again. ABCD is a rectangle. Diagonal AC bisects angle A and angle C. The same point we have proved already in your before problem. Right? Now, they also said it is bisecting. And we need to prove something. That is, show that. 2 sub-questions in this. Prove that ABCD is a square. They have given a rectangle. I need to prove this rectangle as a square. How can it be possible? Rectangle opposite sides are equal, we know. I need to prove it as a square means I should prove sides are equal. If I able to prove adjacent sides are equal, then I can say it is a square. Okay, let's think later. Second sub question. Diagonal BD. Let's draw one more diagonal. BD bisects. Show that this one, children. Observe here carefully. Show that diagonal BD bisects angle B as well as angle D. As similar to the last problem, second part or a second case what we have proved, similarly we need to prove that. Okay, don't by heart any problem, try to understand, then it will be easy this one. Let's start a solution. Given ABCD is a rectangle. ABCD is a rectangle. AC, diagonal AC you can write. Diagonal AC bisects angle A and as well as angle C. To prove, observe here children, you can write the 2 cases. First one, to prove ABCD is a square, and your second one, diagonal BD bisects angle B as well as angle D. First, in your geometrical problems or any proofs or any theorems, understand the question and write in data, and what we need to prove, write in to prove, then start your proof. If any construction there, you can add that point also. Observe this point, diagonal AC bisects angle A and angle C. Here you can write here angle 1 is equal to angle 2 and angle 3 is equal to angle 4. This is already given, right? Bisecting means these two angles equal and these two angles are equal. Now let us start a proof. First one, we try to prove ABCD is a square. I try to prove by taking the angles, children. Observe carefully. Angle 3 is equal to angle 2, I say. Alternate angles. Angle 1 is equal to angle 4, I will say. Let us write here. We know angle 1 is equal to angle 4. Reason, alternate angles, and angle 2 is equal to angle 3. Same reason, alternate angles. Mark this 1 and mark this equation 2. Okay. Now, I cannot compare anything here. But given something, but angle 1 is equal to angle 2. This is given. But they have given angle 1 is equal to angle 2. Mark this as third equation. And one more, angle 3 is equal to angle 4. Mark this fourth equation. This is also given. Now, how can I start my proof? Look here carefully. Alternate angles and these two angles are equal, said. I try to prove that these two angles are equal. If these two angles of any one triangle, children, if I am able to prove these two angles equal, then we say if two angles are equal in a triangle, their opposite sides are equal. If their opposite sides are equal, that means adjacent sides are equal, then this rectangle becomes a square. Is it followed? How we are going to prove now? So what is given and alternate also we have written. Alternate angles we have written here and the given angles we have written. So try to compare two angles. Let me compare equation 1. Angle 1, angle 4 there. Anywhere angle 1, angle 4? Yes, angle 1 there. So comparing equation 1 and 3. Equation 1 and 3. Angle 1 is common. So we can skip these angles and you can equate remaining angles. That is angle 4 is equal to angle 2. Angle 4 is equal to angle 2. Which triangle? Triangle ABC. In triangle ABC, angle 4 is equal to angle 2 said. If these two angles are equal, what I can say? Their opposite sides are equal. If angle 4 is equal to angle 2, then AB is equal to BC, I will say. Angle 4 opposite side is AB, angle 2 opposite side is BC. AB equal to BC. How did we write the statement? If two angles are equal, in a triangle, then their opposite sides are equal. So now I can say that AB is equal to BC I got. In a rectangle, if two adjacent sides are equal, then this rectangle becomes square. Therefore, okay, if two adjacent sides of a rectangle are equal, then ABCD is a square. Rectangle ABCD also you can write. So it may not be visible clearly. So once again let me repeat. If two adjacent sides of a rectangle ABCD are equal, then ABCD is a square. If you try to prove two adjacent sides equal, then I say this rectangle is a square. Okay, is this clear? Now, second proof. Diagonal BD bisects angle B as well as angle D I need to prove. Let me take a rectangle here. Rectangle not, now it became a square, right? ABCD is a square. Diagonal BD. Okay, mark this angle 5, 6, 7, 8. This diagonal BD bisects angle B means You should say angle 5 equal to angle 6 and angle 7 is equal to angle 8. If bisects angle D means angle 7 is equal to angle 8. Let us start this proof. How can we start this one? Proof for second one, if you want, you can write. Just let me discuss with you how we can prove this. Angle 5 is equal to angle 8. Diagonal BD act as a transversal, alternate angles are equal. Angle 5 is equal to angle 8. But I say angle 5 equal to angle 7. How can I say that? Because this is a square. If these two sides are equal, their angles are equal. Right? So now, first one, what did I try to prove? I have proved this one as a square. Okay? Now, these two sides are equal. These two angles are equal. Therefore, angle 5 equal to angle 8, angle 5 equal to angle 7. When you compare, you are going to get angle 7 is equal to angle 8. Similarly, you can prove angle 5 equal to angle 6. This is very simple, but consider any one triangle. Let me consider here triangle ADB. Triangle ADB. I am going to consider this triangle. What I can say? AB is equal to AD. AB equal to AD. How did I say? Because ABCD is a square we have proved before. ABCD is a square. Therefore, adjacent sides are equal. If these sides are equal, their opposite angles are equal. AB opposite angle is angle 7. AD opposite angle is angle 5. Angle 7 is equal to angle 5. But what do you know? Angle 7 is equal to angle 6. What is the reason? Alternate angle. Mark this one. 5 children. Already we have taken up to 4 here. And mark this 6. Now on comparing 5 and 6. Angle 7 is common. You can equate angle 5 equal to angle 6. From equation 5 and equation 6, I say that angle 5 equal to angle 6. Mark this equation number 7. If you want, you can write here diagonal BD bisects angle B. That means angle 5 equal to angle 6 we proved. Therefore, the diagonal is bisecting angle B. Not only angle B, I should prove angle D also now. We know, what do we know children here? I say that angle 5 is also equal to angle 8. Angle 5 is also equal to angle 8. Alternate angles, right? I know that. Alternate angles. But if I compare these two, I say angle 7 is equal to angle 8. That means it is bisecting angle D. Mark this as 8 and we know. See, not only angle 7 equal to angle 6 alternate. I can say angle 5 is also alternate to angle 8. Now, on comparing 5, 8 children, which one will compare? Where is angle 5? Here, this one I will compare. From equation 5 and 8, angle 5 common. Therefore, angle 7 is equal to angle 8. This angle is equal to this angle. And mark this as equation 9. So, finally, angle 5 equal to angle 6 and angle 7 is equal to angle 8. Therefore, from equation 7 and 9, I say that diagonal BD bisects angle B as well as angle D. Diagonal BD bisects angle B as well as angle D. Given ABCD is a rectangle and AC diagonal bisecting angle A, angle C given. Bisecting means angle 1 equal to angle 2 and angle 3 equal to angle 4. How can I prove this? I remember alternate angles. Angle 1 is equal to angle 4, angle 3 is equal to angle 2. Compare these angles and given angles. If you compare, you get in a triangle, two angles are equal. If two angles are equal, their opposite sides are equal. If the opposite sides are equal, that means here these two sides are adjacent sides of a rectangle. In a rectangle, adjacent sides are equal, then it becomes a square. That's all. That is the proof for first one. And your second one, we need to prove that diagonal BD bisecting angle B and angle D. How can we start here? We know that now rectangle is a square. These two sides equal, then their opposite angles are equal. And by using alternate angles, angle 5 equal to angle 8, angle 6 is equal to angle 7. Then we try to prove that angle 5 equal to angle 6 and angle 7 is equal to angle 8. Finally, BD diagonal bisects angle B as well as angle D. Understand the problem carefully and do right now in your notes. Let's see the ninth problem. In parallelogram ABCD, observe here ABCD is a parallelogram. Immediately what you remember? Opposite sides are parallel and they will be equal, right? ABCD is a parallelogram. 2 points P and Q are taken on diagonal BD. Observe here, BD is a diagonal. On this diagonal, 2 points, point P and point Q are taken on the diagonal BD, such that DP is equal to BQ. Such that DP is equal to BQ. To show this DP is equal to BQ, I have marked with a single line. Okay. So understand here what is the problem. ABCD is a parallelogram. BD is a diagonal. 2 points P and Q are taken on the diagonal such that DP is equal to BQ. Show that. See here you have 5 sub-questions in it. See the questions but don't be panic. Problem is very simple. Triangle APD congruent to triangle CQB you need to prove. Where is APD? This one and CQB this one. Just observe the two triangles here. BQ is equal to PD. Two sides are equal. Then what I can say? BC is equal to AD. Why? Opposite sides in a parallelogram are equal. This and this and this equal. Then now what I can prove? This angle is alternate to this angle. In a parallelogram, alternate angles are equal. Therefore, by side angle side, S says congruency rule. I say these two triangles are congruent. That's it. The next one, AP is equal to CQ I need to prove. In your first sub-question, you proved these two triangles are congruent. If they are congruent, by CPCT, we can equate the remaining sides. That means AP is equal to CQ. Over. Second proof. Third one, triangle AQB congruent to triangle CPD. Where is AQB? This one. And CPD this one. Similarly, you can say children, this side equal to this side. Why? Opposite sides of a parallelogram are equal. AB is equal to DC and BQ is equal to PD. Right? Similarly, the interior angles, I can say this angle is equal to this angle. Therefore, by side angle side, SAS congruency rule, I say these two triangles are congruent. If they are congruent, fourth sub-question, AQ is equal to CP, you need to prove. If these two triangles are congruent by CPCT, I can equate remaining sides. Okay. Now finally, last question, prove that APCQ is a parallelogram. APCQ is a parallelogram. You can observe from this one, second and fourth proof, I say that AP is equal to QC and PC is equal to AQ. In a quadrilateral, if opposite sides are equal, then I say it as a parallelogram. Okay, this is the proofs we need to prove for 5 sub-questions, children. Understand problem. It will be very simple. If you try to by heart the problem, you won't understand anything. Yes, will you accept with me? Right? Understand the problem, then try to solve. Suppose if you feel difficulty, watch the problem 2 to 3 times. Every step by step, okay, what is given, what we need to do that. Right? Every 4 lines or 5 lines, understand the problem and do in your notes. Then this quadrilaterals or it might be parallelograms, these theoretical problems will be easy for you. Instead of listening full problem and solving in your book, at least half of you divide yourself and then solve the problem. Let's start our solution with the given data. Given A, B, C, D is a parallelogram. CD is a parallelogram. BD is a diagonal. And still what did they say? P and Q are taken on diagonal BD. You can write BD is a diagonal, children. Next, cut. BD is a diagonal. And if you want, you can extend your points by writing P and Q are points on the diagonal. And what did they give here? DP is equal to BQ. This is your given data. To prove, just please fill up from here to here again. First to 5, all questions you need to write here. To prove means I need to prove all the sub-questions. Proof. Let me start proving with the first sub-question. APD CQB triangles. Consider APD. Where is APD? This triangle. So I write here in triangle APD and triangle CQB. I need to prove they are congruent. So I am not writing congruent symbol here. I have considered 2 triangles. Triangle APD and triangle CQB. So let's start comparing these 2 children first. Given, what is given? APD triangle DP. DP is equal to BQ. Reason, already it is given. Given this equal to this. And next, this triangle you should take first in left hand side. Don't forget. AD. AD is equal to BC. Reason, opposite sides in a parallelogram are equal. Opposite sides in a parallelogram are equal. Okay. Next, what I can say? Angle ADP you say. I should not say angle D. Angle D comes under full complete angle you will get here. So, angle ADP is equal to angle QBC. Angle QBC. Reason, alternate angles in a parallelogram are equal. Therefore, what I can say here? SAS congruency rule, I say that triangle APD congruent to triangle CQB. Which rule, children? SAS congruency rule. These 2 triangles are congruent. Hence it is proved. First proof is proved already. Second one. Let me go with the second proof. I need to prove AP is equal to CQ. We know by above, we know that triangle APD is congruent to triangle CQB. Therefore, by CPCT, corresponding parts of a congruent triangles. what I can say? I can equate that. That is AP is equal to CQ. We know if the two triangles are congruent by CPCT, corresponding sides are equal. Start the third one. Third one, which two triangles are there here? Triangle AQB, triangle CPD. I'm going to consider those two triangles now. In triangle AQB and triangle CPD. Triangle CPD. Observe children in the figure. Now these two triangles you start comparing here. AQB I have written first. So this one you start. BQ. BQ is equal to DP. DP is equal to BQ or BQ is equal to DP. Same. Given. Reason? Given. Next. AB is equal to DC. AB is equal to DC. How we say this one? In a parallelogram, opposite sides are equal. Opposite sides in a parallelogram, shortcut I have written, are equal. You can write neatly by writing full form. Next step. Two sides are equal I got here. Now this angle ABQ is equal to angle PDC. Alternate angles in a parallelogram are equal. According to this statement, angle ABQ is equal to angle PDC or CDP also you can write PDC. This angle is important. This angle is important. Angle B, angle A, this one. So how we are writing the statement here? Alternate angles in a parallelogram are equal. Alternate angles in a parallelogram are equal. So now compare carefully children. Side, angle, side. Side, angle, side. Therefore, by SAS congruency rule, I say that the two triangles, triangle AQB is congruent to triangle CPD. AQB is congruent to triangle CPD. Yes, is this the thing we need to prove? Yes. Go to the fourth one. Fourth one, what I need to prove? AQ is equal to CP. Same manner, we know that by above, we know triangle AQB is congruent to triangle CPD. If they are congruent by CPCT, I can equate the remaining parts. That means AQ is equal to CP. Over. Let me mark this 1 and let me mark this 2. Let's go with the fourth question. Prove that APCQ is a parallelogram. I say that from equation 1 and 2. From equation 1 and 2, what I say? AP is equal to CQ and AQ is equal to CP. From equation 1 and 2, what I say? AP equal to CQ and AQ is equal to CP. Observe here, AP is equal to CQ and AQ is equal to CP. So, in a quadrilateral, if opposite sides are equal, then it becomes a parallelogram. Right here, therefore in a quadrilateral, if opposite sides are equal, then it is a parallelogram. Then it becomes a parallelogram. Hence, it is proved. So they have asked 5 sub-questions in this figure. We tried to prove all the questions. Once again, understand carefully. Given ABCD is a parallelogram, prove these two triangles congruent set. So what did you say? DP equal to BQ given AD equal to BC. Opposite sides in a parallelogram are equal and alternate angles equal set. Then by AS congruency rule, these two triangles are congruent. Similarly, you have proved these two triangles also congruent. If they are congruent by CP/CT, you try to prove that CP is equal to AQ and AP equal to QC. If in a quadrilateral, this is another quadrilateral. See here, 4 sides, it has 4 sides. In this quadrilateral, if opposite sides are equal, then it becomes a parallelogram. Okay, with this, we are going to end our session. In our next session, we are going to continue with the next 3 problems. Until that, keep watching. Thank you all.